Example number 7. The length of a rectangle is 8 feet more than its width. If the area of the rectangle is 84 square feet, what are the dimensions of the rectangle? In this problem, they are talking about the area of the rectangle. We know that the formula for the area is length times the width. Here is the picture of the rectangle. So you have length and the width. And also in the problem, they mention that the length is 8 feet more than the width. The information that we know about the width is very less. About the length, we know that the length is 8 feet more. When we assign the variable, we will assign for the one we know the least information about. We will assign x for the width, and the length is 8 feet more. It means the length is x plus 8. The area in the problem they give to us is 84, and the length is x plus 8. The width is x. We want to solve for this equation. First of all, we need to open the parentheses. We notice that we have the x squared. We think about quadratic equation. So we need to make the 0 in order to solve. We got x squared plus 84 plus 8x minus 84 equal to 0. We will factor the quadratic equation, the trinomial. So we do x and x. So now 84 is 1 times 84, 2 times 42, 3 go to 84. So we divide 84 by 3, and we will get 28. And 4 go to 84 is 21. 5 does not go to 84. 6 go to 84 is 14. The 6 and the 14, the difference between them is 8. So I'm gonna choose 14 and 6 because I'm looking for the difference is 8. It will be plus 14 and minus 6. Then x plus 14 equals 0 and x minus 6 equal to 0. X equal to 6 and x equal to negative 14. We assign the x is the width, and the width have to be a positive number. Because this is the word problem, so we need to eliminate the answer that does not make sense for us. So we answer the question. The width is 6 feet, and the length is 8 feet more, so 6 plus 8 is 14 feet. We can check the problem by multiply the length and the width together. We got the answer is 84, that is the area of the rectangle. Example number 8. A ball is thrown off a cliff by a child from a height of 240 feet above sea level. So here is the picture. So you imagine there's a child and he has a ball. So he threw this ball and the ball will go up, and then later on it will hit the water, right? And they're telling us that the height of the cliff is 240 feet. The height s of the bar above the water in feet as a function of time in seconds can be modeled by the function s of t equal negative 16t squared plus 32t plus 240. A. When will the bar be 240 feet above sea level? And you know that we need to use the information that they give us in the problem. So let me first write out the model of the function. In this model, this is the notation of the function. So you say s of t. S in this case represent for the height, and t in this case represent for the time, and the time in second. So the question asks us when, that means they ask us to find the time. 240 feet they are given to us is the height. So we will plug in 240 feet at the s of t. You say this is s of t, not s times t, okay? And then we have negative 16t plus 32t plus 240. We see the square on the t, so we think about quadratic equation. We need to minus 240 both sides to get the 0. And then we solve this problem by factoring out the greatest common factor. We will factor out the negative 16t, and that will be t minus 2. Negative 16t equal to 0 and t minus 2 equal to 0. Then you divide both sides by negative 16. You get t equal to 0, and plus t plus 2 both sides, you get t equal to 2. So now we can answer the question. The question asks us that when will the bar be 240 feet above the sea level? We answer that the bar will be 240 feet above sea level at the child hand and after 2 seconds. What is the reason why I say so? Now you look at the picture. You look at the bar. So if the bar stays on the child hand, the bar does not travel. We count 0 time, okay? And then when the child throw a ball, then the ball will be somewhere like this. For this both location, from the child hand to that location, it will take 2 seconds. And both location, you look at the water. This is 240 feet. The yellow line is 240 feet above sea level. Now problem B, the question asks us that when will the ball strike the water? The question asks us when, that means we need to find t. The word strike, it means hit the water. the ball will hit the water right in the bottom of the cliff. Then the height will be 0. So that means that we need to find t when the height is 0 and the height is s of t. We will use the model again. The model is s of t equal negative 16t squared plus 32t plus 240. And then we will input the 0 for the height. We see that in this problem 16 go to 16, 16 go to 32, and 16 go to 240 15 times. We will factor out the GCF 16 and the negative 16 also. So we get t squared, 2t, and 15. The t squared will be positive, 2t will be negative, and 15 will be negative. Since negative 16 is a number, there are no variable to solve, you just have to factor the t squared minus 2t minus 15. You will get 5 and 3. Then we just go ahead and set the one that have the variable equal to 0. Then t equal to 5 and t equal to negative 3. We will eliminate the one that does not make sense. So we conclude that the ball will strike the water after 5 seconds.